Do a hillshade algorithm which will combine a map of the San Francisco area and will create the hillshade based on an underlying elevation cell that overlaps the same area. So what we'll do first is go over here and let's drop in our geotiff of our map of the San Francisco area, and also let's drop in a elevation cell of the same area, and make sure that you have full view synchronization so both of them are in the same view so we can combine things together properly. Let's go ahead and zoom out so we can see the whole area. And now what we'll do first is highlight the elevation cell that you see here underneath sources, and we're going to create a image normals mapping, and this is just colorized just so we can see the image plane normals. This has nothing to do with sun colorization or anything, so we don't need this cell up right now, so we'll just close him out, and we'll also close out the elevation window as well, because we don't need him either at this moment. And what we're going to do is make sure that we highlight the image normal mapping, which you see here, and also the color map product that you see there, and we're going to combine them into a hillshade algorithm. So let me go ahead and shrink this back down, and what we're going to do is combine hillshade, and you can see over here the map being hillshaded using the underlying elevation cell. So let's go ahead and zoom in a little bit. If you zoom in a lot, you'll start to see the pixelation of the elevation. So what I'd like to do now is set this to a cubic to make sure that it looks a little bit smoother when we're zooming in. So it'll smooth out the normals to the equations. And let me go ahead and get this over an area that has some pretty good detail there. And what we're going to do now is show you how to modify the parameters of the shading equation. This part will allow you to go to filters, bump shade, properties, control the lighting angles used in the shading algorithms. So let's go ahead and change the azimuth angle. If you want the sun to come from the top, you can set the azimuth angle to 0 and hit return. You'll see over here the shader relief will change. Let's go ahead and change it to 90. You want to come from the right. You want to come from underneath. 180. You want to come from the left. 270 degrees. The angles go from 0 to 360, but we like to use 45-45, which gives us best shading result. Give you an idea what the elevation angle. If it's low on the horizon, it's going to be dark, and if it's directly above, it'll brighten the image out completely. A good number here is also 45 degrees. It gives you a nice gray factor. What we're going to do now is allow you to make these shadows come out and make them more vibrant in the image. So we can go to the normals filter, and we're going to add a gain to the image plane normal calculator. So let's go ahead and drop him down, drop the filters down, and let's give him a gain of like 2. Is a good number. Now, if you go too high, it just starts to look kind of too black, and it gets too blocky looking. So if you want to make them a little bit darker, I'd say the 2 is pretty good. Whoops. So we'll keep it at 2, and let's go ahead and make this a little bit bigger so you can see it better. Image, window, tile. And that concludes the using GeoCell to create a hillshade product out of a map and an elevation cell.